Hi children, good morning everyone. Today we are discussing about refraction of light through a prism. So the light will incident on a prism and how will make a prism by the light. Let's see here. You have learned how light gets reflected through a rectangular glass slab for parallel refracting surfaces. As in glass slab, the emergent ray is parallel to the incident ray. However, it is slightly displaced laterally. How would light get refracted through a transparent prism? See here, in previous sections we have to learn about the glass slab. In the glass slab, when the light is incident on the refracting surfaces, then the light will be emergent ray is parallel to the incident ray. We are observed that slightly. But here, how would light get refracted through a transparent prism? That means transparent glass prism. Let's see. Consider a triangular glass prism. It has two triangular bases and three rectangular lateral surfaces. These surfaces are inclined to each other. The angle between two lateral faces is called angle of prism. Let us now do an activity to study the refraction of light through a triangular glass prism. That means in a prism they have two triangular bases and three rectangular lateral surfaces. These surfaces are inclined to each other. The angle between two lateral surface faces is called angle of prism. So let us do an activity to study the refraction of light through a triangular glass prism. Let me observe the incident ray, emergent ray, and refracted ray. Let us see here. Fix a sheet of white paper on drawing board using drawing pins. Place a glass prism on it such a way that it resets on its triangular base. Trace the outline of the prism using a pencil. Draw a straight line PE inclined to one of the refracting surfaces, say AB of the prism. Let's see here. We have take a prism and drawing pencils and pins. So pen, pencil and prism and drawing board pins. Let's see here. The prism it should be place a triangular base. See, look like this here. So the outer surface to draw with the pencil, so it should be look like a triangular. So the three sides, one is from left hand side, right hand side and lower side of the bases. So you have to draw outer surface of the prism. Then it should be look like a triangular. So in triangular all the angles are equal, and here also we have observed the angle of prism when it is depending upon the instant on a light, but all the angles are equal in the prism. Let's see here how should we look like a shape of the triangular of the glass prism. See here, this is a should be triangular, so A, B, C, and AB and AC are the sides and BC is the base of the prism. Clear? So this is the lateral surfaces of the AB and AC are two faces, and the BC is the base of the prism. Now draw a perpendicular line side of the AB using by protractor and take a middle point of the AB, and so you have to put a protractor like 90 degrees. Then take a point node and draw the perpendicular line of AB side. So that is the normal of the AB. Let's see. Fix two pins. Draw a straight line PE inclined to one of the refracting surfaces, say AB of the prism. Let's see here. So P to E line is called as incident ray. So it should be angle of between normal and PE line is angle of incidence. Let's see here. Let fix 2 points, say at points P and Q on the line P as shown in the figure. So in PE line we have to put 2 pins like this. On AB side of the prism we have to fix a 2 pins of PE line, that is P to E line means that is incident ray. And now look for the images of the pins fixed at P and Q through the other face AC. So that means in other side of that means AC face you have to observe PQ pins and look a place a pins look like that RS, that means fix 2 more pins at points R and S such that the pins at R and S and the images of the pins at P and Q lie on the same straight line. So it should be look like a same straight line. Let us see here. So we have observed the side of AB side, the 2 green pins. We have observed the other side of AC and should be put yellow pins like that, same straight line of green pins. So it should be clearly we observe the other side. See here the other side, the inside the prism, the AB side of the green pins are refracting in prism. In the prism we are observed clearly we should put yellow pins like a straight to green pins. See here, straight to green pins we have to putting like this, then we have clearly it should be look like a straight line. So that's why the AB side of the green pins and AC side of the yellow pins are, it should be look like a straight line. So that's why it is lying on a same straight line. Do you understand? So in the prism the 2 faces are, the refracting light is in a straight line. I don't understand. See, it should be look like a, on the other side we have to observe a clearly it should be a straight line. Then remove the pins and glass prism. The line P meets the boundary of prism at point E. Similarly, join and produce the points R, S. Let these lines meet the boundary of the prism E, F respectively. Join E and F. Join E and F. Draw the perpendiculars to the refracting surfaces AB and AC of the prisms at points E and F respectively. That is normals. See here. RS line should be going on here. So here that AC is perpendicular line is M and AB is perpendicular line N. These are the normals of the 2 sides of the prism, AB side and AC side. Do you understand? So here we can get identified PE is incident ray, EF is refracted ray and FS is emergent ray. See here, P is incident ray, EF is refracted ray, FS is emergent ray. Let angle A is angle of the prism. That means the 2 lateral faces of the prism, AB face and AC face. So in A position, the angle of the prism, that is the angle of prism. Now angle I, angle of incidence. See here, angle PEN, angle of incidence. Angle R, angle of refraction. Where is the angle R? See here, angle R. That means at E position, ENF is the angle of prism. Sorry, ENF is the angle of refraction. That is angle R, angle of refraction. That means N dash, M dash is the normals of the 2 faces of AB and AC. Now see, angle of emergence. Where is the angle E? Angle E can placed by MFS. Angle MFS is called a angle E. That is angle of emergence, that is angle of emergence. If RS is extended to Z and P is extended to G, we have to gain one angle, that is angle of deviation. Angle of deviation. So this is enter the angles of the prism. Now here P is incident ray, EF is refracted ray, and PS is the emergent ray. You may note that a ray of light is entering from air to glass at the first surface of AB. That means when the light ray is entered into the two mediums, one is air medium and another one is glass medium. So AB surface outside the air medium, AB surface inside the prism is glass medium. Now the light ray on refraction has bent towards the normal. The light ray is bent towards the normal. At the second surface of AC, the light ray has entered from glass to air. So in second case, so after the refracting, the emergent ray gets from glass medium to air medium. Glass medium to air medium. So that's why the entered from glass to air. Hence it has bent away from the normal. Compare the angle of incidence and angle of refraction at each refracting surfaces of the prism. So we have to compare these two angles. One is angle of incidence and another one is angle of refraction. That each refracting surfaces of the prism is similarly to the kind of bending that occurs in a glass slab. Therefore, the peculiar shape of the prism makes an emergent ray bend at an angle of the direction of the incident ray. This angle is called angle of deviation. So we observe in the figure in case angle D, the angle of deviation. Mark the angle of deviation, the above activity, and we have to measure it. So finally we have to measure a angle of deviation from this refractive index of the prism, that means glass prism. So this is enter the diagram of refraction of light through a prism. You understand? So please draw it and practice. So you make a practice well for this diagram. It is very important for this chapter. So tomorrow we will discuss about to measure the angle of deviation. Okay, thank you.